Alrighty, today we'll be doing section 1.3, use midpoint and distance formula, day 2, and today the focus will be the distance formula. So the distance formula is if point A and point B are the points in a coordinate plane, then the distance between A and B is, and so the distance formula is D equals square root, make that nice and long, x2 minus x1 squared plus y2 minus y1 squared. So we'll have to solve everything inside the parentheses first, then add them together, and then the square root of those. That is the distance formula. So let's put it in action. Find the length of the segment. We see we have a point at E and F. So E is at -2, 3. So we can go ahead and call that x1 and y1. And then F, point at 5, -3. So we can call that x2 and y2. And then we just need to plug those numbers into our distance formula and solve for the distance between E and F. So EF, which is our distance, equals long square root x2, which was 5, minus x1, which is -2, that'll be squared, plus y2, which is -3, minus y1, which is 3, and all of that squared. So 5 minus -2, we've got double negatives, so 2 negatives make a positive. So that becomes 5 plus 2, which is 7. So we have 7 squared plus -3 minus 3 will give us -6. So we have -6 squared, all under the square root. So 7 squared is 49, and -6 squared is 36. -6 times -6 will give us a positive 36. Then we can add those together. 49 plus 36. And we get 85. And then here you'll probably want a calculator and type in square root 85. And we're going to round to the nearest 10. So it's going to round to 9.2. So that curvy, what looks like an equal sign, but it's curvy, just means approximately, which shows that we rounded it. So approximately 9.2. All right, now you try. Find the length of the segment. So go ahead and pause, solve this on your own, and then unpause and we'll go over the answer. All right, hopefully you had a chance to do that on your own. Let's look at our points. We have a point at -2, 7. A point at -8, 3. We can call negative 2, 7 our x1, y1. Negative 8 can be our x2. And 3 our y2. And I could have done that the other way. Negative 2, 7 could have been the x2, y2. That's okay. Then we need to plug those into our distance formula. Actually, don't have names for the point. You can name them maybe if you want. But we're still solving for our distance here. So we have negative 8, that's our x2, minus negative 2, which is our x1, all of that squared, plus y2, which is 3, minus y1, which is 7, and that's squared. So just showing all the steps. Negative 8 minus negative 2, we've got a double negative there, so that becomes negative 8 plus 2. That'll give us negative 6. And then 3 minus 7 will give us negative 4. And that'll be squared. So then go ahead and square each of those. Negative 6 squared gives us 36. And negative 4 squared gives us 16. Add the two together. You should have gotten 52. And then when you punch the square root of 52 in your calculator, remember round to the nearest tenth if you get a decimal, and we should get 7.2 after we round. So approximately 7.2 is the distance of our segment. Right, so here we have the endpoints of two segments that are given. We need to find each segment length to the nearest tenth if needed and tell whether the segments are congruent. So we'll do one together, you try the other, and then we'll be able to tell if they are congruent or not. So looking at RS, so we have, let's look at R, we can call that X1 and Y1. S we'll call X2 and Y2. Make sure you match up the X's with the X's, Y's with the Y's. X is always listed first. So RS equals a long square root sign. We have X2, which is 0, minus X1, which is 5, squared, plus Y2, which is 4, minus Y1, which is 4, squared, so we have negative 5 squared, 0 minus 5 is negative 5, and then 4 minus 4 gives us 0. Then just square each of those. Negative 5 squared gives us 25, and 0 squared is 0. RS equals the square root of 25. Punch that into your calculator and you should get RS equals 5. Or hopefully you know that 25, the square root of 25 is 5, since it is a perfect square. So we know RS is 5. So go ahead and pause. Find the distance between T and U. And then unpause for the answers. All right, hopefully you work those through. And we should have, let's go ahead and call our points. X1, Y1, X2, Y2. So TU, we have negative 1 is our X2 minus negative 4. That'll be squared plus y2, which is 1, minus negative 3. And that'll be squared. So negative 1 minus negative 4 becomes negative 1 plus 4, which gives us 3. And then 1 minus negative 3 becomes 1 plus 3, which gives us 4. Square each of those. We get 9 plus 16. 9 plus 16 is 25. And the square root of 25, which we just figured out on the other side, is 5. So we found both of the segments, but what else does the question ask for? It says, tell whether the segments are congruent. And congruent means the same, or that they're congruent. So yes, they are congruent. Sort of a three-part on that one. We found RS, we found TU, and we identified that they were congruent. That is it for the notes for today. Have a wonderful day.